Okay, good morning, children. Today we are doing a new chapter uh, that is redox reaction. This chapter, as you know, is coming in the exam. So I'll be covering this chapter and the entire chapter through these videos. You know, redox is actually a combination of two terms, reduction and oxidation. Suppose we have a reaction H2 plus CuO, H2O plus Cu. This reaction can happen in this way. Suppose in a closed chamber we have here copper oxide. Copper oxide is being heated. And through a inlet we are passing into a hydrogen gas. So hydrogen gas is being passed over heated copper oxide. Then this reaction will take place. So as you can see, in this reaction, water and copper is being formed. So if you see this chain H2 to H2O, if you see this chain H2 to H2O, there is addition of oxygen. And if you see copper oxide to copper, what has happened is there is removal of oxygen. So H2 to H2O, addition of oxygen. CuO to Cu, there is removal of oxygen. Now you have read in your previous class about oxidation and reduction. There you have learned that addition of oxygen is oxidation, removal of oxygen is reduction. So we can say that this process is oxidation and this process is reduction. So we are seeing here is that oxidation and reduction are taking place simultaneously, and such a reaction where oxidation and reduction take place simultaneously are called redox reaction. This is one concept of oxidation reduction. This is actually the old concept. So according to old concept, oxidation is defined as addition of oxygen or any electronegative element, and oxidation is also removal of hydrogen or any electropositive element. In the same way, reduction, you have learned before that reduction is addition of hydrogen or any electropositive element. Reduction is also can be defined as removal of oxygen or any electronegative element. What is electronegative element? Suppose Cl, sulfur. These are electronegative elements, whereas sodium, potassium, metals, these are electropositive elements. Now there is a modern concept of oxidation and reduction that we should try to understand now. This is old concept of oxidation and reduction. Suppose we have in this container we have, say, uh, copper sulfate solution. We have copper sulfate solution. You know, copper sulfate solution will be blue in color. And we have a zinc rod. So copper sulfate and zinc we have. So you know there will be a chemical reaction. This chemical reaction you have also studied in class 10. The chemical reaction that will take place is Zn solid plus copper sulfate aqueous, arrow, zinc sulfate aqueous plus copper solid. So this is a reaction that happens. You have read in class 10 in this way that zinc is a metal more reactive than copper. That's why zinc will displace copper. Zinc will displace copper, and that's why this reaction happens. And how will you understand that this reaction is taking place? Here, now since we know copper sulfate is blue colored solution, then as this reaction takes place, or you will see when zinc rod is kept here, you will see that the color, the blue color of the solution, the intensity of blue color of the solution will decrease. The intensity of blue color of the solution will decrease, and this will show that there is a chemical reaction taking place. Now, children, this is also a redox reaction. This is also a redox reaction, and how can we understand this? We can do so in terms of a modern concept. Now, this reaction we can rewrite in this way: ZnS plus copper sulfate, is a ionic compound, so it consists of ions. Copper sulfate consists of ions. Is copper plus 2 ion and sulfate 2 minus ion. Similarly, zinc sulfate consists of ions. So this reaction we can rewrite like this. So now you see we can cancel out same thing from both sides. So what can we cancel out is this sulfate ion. We cancel with this sulfate ion. That means we are left out with Zn solid plus Cu plus 2 aqueous, arrow, Zn plus 2 aqueous plus Cu solid. Now you see, if you see the change in this way, zinc to Zn plus 2, zinc to Zn plus 2, there is what is happening? Loss of electron. Loss of electron is taking place, 2 electron. And according to modern concept, according to electronic concept, loss of electron is called oxidation. Loss of electron is called oxidation. So this process is oxidation. And you see copper plus 2 to copper plus 2 to copper, there is gain of 2 electrons. Gain of electron, that is plus 2e, and gain of electron according to modern concept it is reduction. So this is reduction. So you see this reaction or this reaction, there is oxidation and reduction taking place simultaneously. So it is an example of a redox reaction. Now you should also know what is the oxidizing agent, what is reducing agent. The species which helps in oxidation, is oxidizing agent. Species which helps in reduction is reducing agent. Say here in this case, this copper oxide is oxidizing agent. This hydrogen is a reducing agent. Since this step is, as you have seen, it's reduction, and this reduction is actually being helped by this hydrogen. So hydrogen is a reducing agent. This step, oxidation, it is actually being helped by copper oxide. So copper oxide is the oxidizing agent. In the same way, zinc here is the reducing agent. Reducing agent, you should remember, reducing agent supplies electron. The reducing agent is a supplier of electron. It supplies the electron for this step. In this step electron is required, and this electron actually comes from zinc. Zinc is a supplier of electron. So zinc is a reducing agent. A reducing agent, after carrying out reduction, gets oxidized. So you see zinc, we can say zinc reduces copper plus 2 and itself get oxidized to Zn plus 2. Similarly, copper plus 2 is the oxidizing agent here. Copper plus 2 is the oxidizing agent here. Copper plus 2 helps in the oxidation. This one is oxidation. And what is oxidizing agent? Oxidizing agents are substances which accepts electron. This you have to know. Oxidizing agents are substances which accept electron. So, you see, zinc, which is supplying electron, that is gained by copper plus 2. So that's why copper plus 2 is the oxidizing agent. And oxidizing agent, after carrying out oxidation, get itself reduced. Copper plus 2 is changing to copper. So copper plus 2 is getting reduced. So, so this is about oxidation and reduction, and like one question I would like to give here. You can practice as a practice question that the question is that show this reaction your copper plus silver nitrate to form copper nitrate plus silver. Just like this, suppose we have a copper rod dipped in silver nitrate solution. If we have a copper rod dipped in silver nitrate solution, then this reaction is going to take place. So copper is solid, silver nitrate aqueous. This is aqueous, silver is solid. So you have to show that this is a redox reaction. You have to show in this way, you have to show that it is a redox reaction. Let me balance this equation for you. It is nitrate is 2 times, so this is 2 here, 2 here. So this is a practice question for you. Is show that this reaction is a redox reaction. Okay, now I would like to give you the concept of oxidation number. Oxidation number or oxidation state. What is oxidation number or what is oxidation state? What is oxidation and reduction in terms of oxidation number? These all I am going to say now. Okay, so suppose we have a chemical reaction H2 gaseous plus Cl2 gaseous forming HCl gaseous. We can rewrite this way: H bond H gaseous plus Cl bond Cl gaseous. H bond Cl gaseous. Okay, now what is oxidation number or what is oxidation state? What is oxidation number or oxidation state? Suppose HCl, this substance, here there are 2 electrons. That 2 electron has been provided, one by hydrogen and one by chlorine. Now you know this thing also, that chlorine is more electronegative than hydrogen. Chlorine is more electronegative than hydrogen. So if we imagine or if we try to carry out the cleavage of this bond, breaking of this bond, the bond will break from here. That is, there will be heterolytic fission. There will be heterolytic fission, and the 2 electrons present here will be taken away by chlorine. So after the cleavage, it will be like this: H and Cl. Both this electron will go to chlorine. And hydrogen, since it has lost its contribution of electron, so it will become plus, and chlorine will become minus. Chlorine will become minus. And since it is plus or it is plus 1, we say that oxidation's number of hydrogen here is plus 1, oxidation number of chlorine here is minus 1. So this is oxidation number. So what is oxidation number? Is we have to imagine separation of atoms, separation of constituents that is present in a molecule, and on doing separation, the charge that resides on them, is the oxidation number. Let me give you another example. Say water. Water is H2O, which is like this: H bond O bond H, and there is also 2 lone pairs in oxygen. So if I ask you what is the oxidation number of oxygen in water, what is the oxidation number of hydrogen in water. So for that, we have to, as already said, we have to separate the constituents. And if suppose we are breaking this bond, HO bond, we are breaking, and since oxygen is more electronegative than hydrogen, naturally the bond will break from here. Bond will break from here, and the 2 electron will go with oxygen. So it will become H with no electron, so it will become plus. And similarly, if this bond will also break from here, so this also will become plus with no electron, and this O will have how many electrons? From this bond 2 electron will be here, this bond 2 electron will be here. So O will be having here 8 electron in the outermost shell. O is having 8 electrons in the outermost shell. Now, normally oxygen has how many electrons in the outermost shell? Normally oxygen has 6 electrons in the outermost shell. We know that. Now oxygen is having here 8. How much more than 6? 2 more than 6. So here charge will be -2. Charge will be -2, and we say that oxidation number of oxygen in water is -2. Oxidation number of hydrogen in water is +1. So this is the concept of oxidation number. Okay, and now we have written the oxidation number here. Now suppose, what is the oxidation number of hydrogen in H2? It is 0. Oxidation number is 0 here. So how it is 0? Let me explain this one also. Like hydrogen is this one. There is 1 electron here, 1 electron here. Now, in order to break this bond, the bond will break from here. Here there will be homolytic fission, and after the breaking of the bond, it becomes H dot plus H dot, and you see normally hydrogen has 1 electron only in the outermost shell. Here there is 1 electron in the outermost shell. So there is no charge. There won't be any charge here. That's why we say oxidation number of hydrogen in H2 is 0. The same way oxidation number of chlorine in Cl will also be 0. Okay, so oxidation number has been written. Now you see we write here 0. We write here 0 oxidation number. Here it is +1. Here it is -1. Now if you see from here to here, 0 to -1. 0 to -1, what has happened? There is increase in oxidation number or decrease in oxidation number. 0 to -1, there is decrease in oxidation number. Decrease in oxidation number. And decrease in oxidation number is called reduction. Decrease in oxidation number is called reduction. And you see from here to here, (0 to +1). 0 to +1, there is what? Increase in oxidation number. And increase in oxidation number is called oxidation. So you see here also reduction and oxidation are taking place simultaneously. So it is a redox reaction. So you should remember this concept also, that oxidation is defined as a process of increase in oxidation number and reduction is the process of decrease in the oxidation number. So let me quickly do another example of like this type. Suppose we have H2 gaseous plus N2 gaseous, arrow NH3 gaseous, balanced chemical equation, will be 2 here. So this is the balanced chemical equation. Now oxidation number of hydrogen here will be 0, oxidation number of nitrogen here will be 0, and ammonia, since ammonia is this, so after the bond breaking, it is going to be like this: H, N, H, H. So this hydrogen will become plus, this hydrogen will become plus, this hydrogen will become plus, because they are losing its share of electron, and nitrogen, it will become like this. Nitrogen will be getting 8 electron in its outermost shell, and nitrogen, has normally has how many in the outermost shell? Nitrogen normally has 5. Nitrogen normally has 5 in the outermost shell, whereas here nitrogen is getting 8, 3 more, so it will be minus 3. So oxidation number of nitrogen here is minus 3, hydrogen here is plus 1. So these are the oxidation number written. So you see from here to here, 0 to plus 1, 0 to plus 1, there is increase in oxidation number. So this is oxidation, and 0 to minus 3, this is decrease in oxidation number. So this is reduction. And oxidizing agent, okay, if this is reduction, this one will be your reducing agent. Reducing agent does the reduction, and oxidation number gets increased, if you remember. And nitrogen is the oxidizing agent, and an oxidizing agent carries out oxidation, and its oxidation number get decreased.